Right, this is a 12 volt 2 amp power supply. A friend of mine recently gave me a few of these. I'd like it to be 15 volts, so I might modify this. I'll just have a look at the quality of it. Don't look too bad. I mean, we've got a fuse on the input, we've got the filter in, the capacitor and the common mode choke. There's no NTC thermistor, that's been jumpered, but it don't look too bad. There's a nice isolation slot, and obviously a nice wide isolation gap across the transformer. Transformer looks reasonable quality. Even got an output filter choke as well. Yeah, I think this is worth modifying. Sorry about the focus there. So to modify this, we need to look towards our feedback, and that's done through this 431 shunt regulator and the opto isolator. So that just tells the transistor to increase or decrease its duty cycle, obviously on the demand on the output. So we just need to target there. There'll be a feedback network of resistors, obviously going to be on the underside, so we'll flip it over. And there they are. So we'll get this set up on an isolation transformer, and we'll target these feedback resistors to the 431, and we'll adjust the voltage on this hopefully. Right, so we've got this set up. We've got an isolation transformer, a series lamp to limit the current. If we get anything like a short circuit, then obviously the lamp will light and save blowing anything up. There we go. Demonstrate that. That's the output voltage monitored. So we'll set up now to do the modification we need to do to this. So the way this works is there's a divider network on the output, and that's a feedback to the opto. So obviously it's a divider, so we need to find the resistor that when we decrease its value, the output voltage rises. Obviously we don't want to be desoldering and putting in a higher value on the other side, so we want the one that when we add a resistor in parallel with it, the voltage increases. That'll make our life easier. So what I'm going to do is take this pair of crocodile clips and trap a high value resistor in here. This is about 70k, I do believe. So the next thing I'll do is I'll attach my two probes here. I'll show you that now. So these are just normal multimeter probes. So now, between the tips of these two probes, we've got 75k. Now, we're going to look at the board, try and identify the resistor that we want, and then we're going to test that theory by putting this resistor, this 75k, in parallel with it, and just see if the voltage moves at all. So we'll go looking for that resistor now. So I think I've identified the resistor that we're after, so we'll just keep an eye on our meter while we probe across this. We're just putting the 75k in parallel with this resistor now. And there we go, the voltage increased to 12.38. So that's definitely the resistor. So now we need to work out what resistor we need to put in parallel with this to get our 15 volts. And I'll show you how we're going to do that. Hopefully you can see we've just snuck in there and we've attached two pieces of mod wire across that resistor. Those 2 points are actually across that resistor that we're interested in. It's RF2. Okay, so now we've got this pot soldered across that resistor, the feedback resistor. So now when we adjust this pot, we should be able to see our voltage increase. So we'll just increase this pot now until we get to the voltage we want, which is 15 volts like I said earlier. So here we go, you can see the voltage is climbing. Whoa, overshot it. So somewhere around there seems pretty nice. So what we'll do now is disconnect that pot, we'll measure the value of it, and we'll find a resistor of that value, and we'll solder that permanently in place. So I just carefully measured that pot, and it looks like we're looking for a 4k resistor. We'll try a 3k9. If that doesn't work, obviously we'll have to put an extra 1k in series with it. So we'll get on with that now and see how that works. So I found a 3k9. We'll just put that across the resistor. So we'll just see what happens now. We'll hit the power. Perfect. That's our 15 volts we wanted, so we'll just solder that in place on the board now, and then we'll be able to. So that's our 3k9 resistor. It's a 1/8 watt, really small resistor, and as you can see, it's tacked in place. I mean, there's loads of clearance, we don't need to worry about that. I don't think I even need to worry about securing this resistor. I think that'll be fine there. So we'll give it one more power up and we'll check the voltage. Give this a little clean with a bit of isopropyl and a toothbrush, get the flux off, and that'll be us done. So let's just check the output voltage again. We'll flick on the power. There we go, 15.1 volts, that's good enough for me. Right, so we'll get this button back up.